Explain construction of meter bridge used in laboratory. First, I show you a figure, the construction, how to construct the meter bridge, right? The figure of meter bridge. First, we have a one board, a one wooden board, and some cross section area, some wires. We have some specific wire like this. Okay, the uniform specific resistance. Two steel plates. A બે સ્ટીલની plates છે. A third one, the steel, and this is a wire. This wire length is 100 centimeter or else 1 meter, right? We have some connection over here. At this 2 point, we are connecting one resistance, that is R. At this 2 point, we are connecting another resistance, its name S. We have two another resistance on this wire, but first we study about galvanometer G. What is use of galvanometer? So we are just find out a small current in this galvanometer. And another point of this galvanometer, we connected a jockey key. If galvanometer deflection will be 0 at this point, its point name is null point. So this length is suppose L1. Total wire length is 100 centimeter. This length is L1. So this length is 100 minus L1. So between the two end A and C, so we given to this two end the name of A and C, and this point it is called B. So between two ends A and C of wire, battery, switch, sometime rheostat is connected in this circuit. The galvanometer using two terminal at a middle of metal point. આ point ને metal point સાથે આપણે middle point સાથે use કરીશું. A second end of galvanometer connected with jockey key, this one, and this can be moved on bridge by keeping in contact with the wire. This is known as construction of meter bridge used in a laboratory. Now we have another question regarding to meter bridge. Explain how value of unknown resistor can be obtained by using meter bridge. So we have a same circuit. So now in one gap meter bridge, unknown resistance R and second gas resistance S from resistance box is connected. We have a two resistance. We have a two resistance here. One is S and another one is S. Suppose we know that the S, so we find out S. Suppose we know the S, so we find out the R. We have a total 4 resistance over here. First is R, another one is S, third one is L1, and fourth one is 100 minus L1, it is called L2. So we have using a Western bridge condition. We have using from Western bridge condition. So we have a Western bridge condition equation. So R1 upon R2 is equal to R3 upon R4. We have a 4 resistance over here. R1 it means R, R2 it means S, R3 it means L1, and R4 it means 100 minus L1, right? So from the principle of Western bridge, from principle of Western bridge condition, the balance condition for balancing, or else we are using on this name from this figure. It is A, it is C, it is B, and it is D. So we have using for this name also. It is R. R we are using between A and B. So AB, and this point is S. We are using S between B and C. So B is upon B into C. It is L1, the L1 between A and D. So AD, and 100 minus L1 disconnected with C and D. So divided by CD. So now we have a equation for meter bridge. It is R upon S is equal to L1 upon 100 minus L1. Unknown resistance can be obtained. Suppose we have unknown resistance is R. So now unknown resistance equation, just a minute, unknown resistance R is equal to S into L1 upon 100 minus L1, or else L upon 100 minus L1. For different value of S and R, the average value can be eliminated. By using meter bridge, value of small resistance can be known. So we have a 4 resistance over here. First connected between A to B, it is named as R. Second one, we are connected between B to C, that name is S. Another point L1, the resistance number 3, uh, if galvanometer deflection will be 0, it is called null point, that is point D. So between A and D, it is the length of this is L1, and D to C, this is length of L2 is equal to 100 minus L1. So we have a principle of Western bridge. So principle of Western bridge equation is R1 upon R2 is equal to R3 upon R4, or else we have equation now R upon S is equal to L1 upon 100 minus L1. So this is the meter bridge circuit or meter bridge equation. Thank you.